This is Josh White with JW Math Tutoring. Today's video is going to cover the digital SAT practice test number 3, module 2A, the easier of the two second modules from the math section of this test. So let's get right to it.
But life is a dream the calculus could never predict.
All right, this is module 2A, the math section of practice test 3 from the Bluebook app for the digital SAT. Again, this is the easier of the second modules for the math section of practice test 3. So, a couple things just keep in mind. Of course, if you like this video, please do give it a thumbs up and subscribe to my channel, sign up for notifications. And also keep in mind that for some of these problems, I may show multiple methods you can use to solve them. So therefore, the time, that I take to go through all 22 questions will probably be longer than the time that you're allotted for on the test. All right, so with that being said, question number 1, what is 10% of 470? So that's just basically doing 0.10 times 470, and that's just going to give us 47, which is the correct answer, letter B. I just want to point out one thing as well. In Desmos, you can just type percentages in. 10% of 470. Right there, 47 get the answer. So even if you didn't know that 10% was 0.1 or got confused about it, you can just type a percentage question in and just have Desmos calculate it for you right away. All right, next we have a bar graph here, basically a histogram. And how many students chose activity 3? Well, we don't know the exact number here because it's between 35 and 40. It looks closer to 40, obviously, than 35, so maybe like 38, 39. But when you look at the answer choices, 39 is the only one, that's in that range or around those numbers that makes sense. So its correct answer is going to be letter B, 39. Next one, question 3. Here we have a basic linear equation. So you can just go ahead and you could subtract this. Then you could get 4x equals 160. X is going to equal 40. So the correct answer is going to be 40. Also, just as a reminder, of course, equations can be solved in Desmos. So just real quick, show this if you haven't seen it. We would just graph 4x plus 5. That's a line. We would graph 165, although it's got to be make it y equals 165, expand this. Obviously, we're going to have to zoom out. There we go. Where do they intersect? Okay, they intersect at the point 40, comma 165. So what's the solution? Well, we just want the x value, so x is 40. All right, next up, number 4, another student-produced response question here. Basically, oranges are $3 a pound. If you spent $27 to purchase oranges, how many pounds did you purchase? Well, it's just 27 divided by 3, or 9 pounds. Another way to think of it, $3 per pound times how many pounds got me to a total of $27. And then you just divide by 3. So correct answer for this is 9. And we can move on to the next question. All right, so here you have a basic linear function, and they want to know where does it equal 8. So you can just set 8 equal to 4x, divide by 4, and get x equals 2. So 2 is the correct answer. And of course, you could also just do this on Desmos. Graph the line y equals 4x, and then just go see on the line where it is equal to, where it has a y coordinate of 8. And you would trace along, and you would see it happens at x equals 2. Next up, we have a quadratic function, but this is the same exact type of problem where they basically want to know what is the x value that corresponds to this y value of 25. So you could just do 25 equals x squared plus 9. And then if you solve this, x squared equals 16. X is going to equal, because we're going to square root both sides, plus minus, positive 4 or negative 4. So only positive 4 is there, so letter A is going to be our correct answer. You could also just, back solve this one. You could take the answer choices, plug them in to the original function. So start with A, 4 squared, 16. 16 plus 9, 25. Does that match what we're looking for? Yes. Well, that's the correct answer then. So you could back solve this for method 2. And of course, method 3, you could just go to Desmos and you could uh, graph it out. So basically we got x squared plus 9. Okay. All right. What is the x value that corresponds to, so we're looking at 4, 5, 9, 13, to a y value of 25. You can see right here it is, if I can get right on top of it, 425. Difficult to say in the exact point, but you get the idea. It's like going to give us 4 because all the other ones are going to be much larger, 5, 9, and 13. Okay, number 7, here we have a graph. They just want to know what the y-intercept is. Of course, the y-intercept is the point where x has a value of 0 and it crosses the y-axis. So it's just the point here, 0, 8. Letter D, nothing else to do for this question. All right, question number 8. This person is renting something. It costs $11 per day, and there's also the one-time fee of $10. And they want to know which of these equations matches, the total cost. So $11 per day means we're going to have to take 11 and multiply that by D, the number of days, in order to get the total per day cost for whatever time period. And then, of course, we have to add the $10 one-time fee to that. So the correct answer for this one's going to be letter C. Now, just to mention, you could also do this one by picking numbers. You could say, for example, let's say I want to rent the thing for 2 days. Okay, how much would I expect it to cost? So 11 times 2 and then add the $10 in. So 22 plus 10, okay, $32. Go through all these answer choices, plug in 2 for D, and see which one equals 32. So in A, 2 plus 10 is 12. 11 times 12 is not 32. It's going to be 132, I believe. Then for B, we have 2 plus 11 is 13. 13 times 10 is 130, not 32. C is basically the same exact thing I just did. 11 times 2 is 22 plus 10, 32. That checks. And lastly, 10 times 2 is 20 plus 11 is 31. That does not match what we would expect. Okay, so again, you could pick numbers and plug them in, figure out what the cost should be, and then compare that to what they work out in the answer choices of the formula. All right, next up, number 9. Here we have two rational expressions that are being subtracted. So just to show you the way you would do this by hand first, and then I'll show you the quick and easy way to do it in Desmos. If we get a common denominator, so you'd multiply the first one by x plus 1 over itself, and the second one by 4x minus 5 over itself. Now, we have a common denominator on the bottom of x plus 1 times 4x minus 5. And on top, so you're going to distribute 4x plus 4. Then you're going to get 4x minus 5. But keep in mind there's a minus sign here which applies to both of these two terms. So it's going to make this positive 4x negative, and it's going to make this negative 5 positive. Now when you combine your like terms, 4x minus 4x cancels out. 4 plus 5 gives you 9, so it should be 9 over x plus 1 times 4x minus 5. So which one is that? That gives us letter D. So that is the correct answer. Now, here's how you could do this entire thing in Desmos. So again, Desmos can be used when you're trying to match equivalent expressions. So I'm going to graph the first one. Okay, I don't really care what the graph ends up looking like. The whole point is I am going to now type in the answer choices and see which one matches it and overlaps it. So This one, notice initially it looked pretty close, but when I zoom out here, I can see parts where they are not identical. Like there are some parts where they are, but for it to be the identical expression, they have to be completely overlapping, meaning when I turn one on and off, I should see the exact same graph. Okay, that's not the case for that one. So let's see, since C is actually identical to A, I'm just going to go ahead and do that one. So I put the minus in. Nope, doesn't work. Again, still kind of close. Um, Actually, I'm going to just go ahead and do D, get rid of that. Okay, so now notice these are completely identical because if I turn one off, same graph. Turn it back on, turn this one off, same graph, doesn't appear. Okay, so that just confirms that D is the correct answer to this problem. All right, number 10, here we have a graph of a line, and they want to know which thing gives the table of values that corresponds to this graph. So notice we have a couple points here. Okay, we've got 0, -5 right here, y-intercept. So we got 0, -5. We've got 1, -3. And it looks like we've got 2, -1. Okay, so now if we scroll down, look at some of these answer choices. So starting with A, 0, 0. Does it have 0, -5? Nope. Eliminate it. Same thing with B. Eliminate it. C, 0, -5. Check. 1, -7. No. Eliminate it. It's going to be D by process of elimination, but you can also see when you look at it, all three of the points match, the 3 points I got from the graph. So correct answer is D. Don't need to do anything else for this question. 11, here you have a basic geometry question with some parallel lines. So S and T are parallel, that's given. They want to know what the value of x is. So multiple ways you could figure this out. I mean, first of all, this angle right here is 110. This angle up here will also be 110 because they're corresponding angles. And 110 and x will add up to 180 because they're basically adjacent angles that form a straight line, or otherwise known as a linear pair. So x is just going to equal 70. So the correct answer for this is 70 degrees. Alternate way to think about this, you could notice that this angle that you're given is 110. This angle here will be 70 because these two angles are same side interior angles, which are supplementary. Therefore, they add up to 180. So this angle is 70 degrees. This angle is a vertical angle with x. Therefore, it also has to be 70 degrees because vertical angles are always congruent. So however you want to think about it, correct answer is 70 degrees for this question. All right, next up we have number 12. So what's the perimeter of a rectangle with a length of 4 inches and a width of 9 inches? So, all right, I guess I probably didn't draw this to scale, but that doesn't really matter because I can just draw it and label it. So you could just go through and add them up. 9 plus 4, 13. 13 plus 9, 22. Plus 4 is 26. Or you could just use the formula 2L plus 2W. 2 times 4 plus 2 times 9. 8 plus 18 gives me 26 as well. So correct answer is letter D. All right, on this question, we have a formula which has several different variables in it, and they want it to be solved in terms of j. So all you have to do here is just divide both terms by 8. Now, notice they actually kept it as one fraction, so they technically just did the whole thing and then just put it over 1/8. So the correct answer here is going to be letter D, k plus 15m over 8. Now, you could technically use picking numbers for this, where you could like pick a number for k and pick a number for m and plug those in and then figure out what j has to be based on that. But it's going to be so much work for a problem that just solving it directly, one step divided by 8 is just much quicker and much easier. All right, here we have a point, and it wants to know which of these is it a solution to. These pairs of linear inequalities. So easiest way is to notice, okay, that the x value is positive. So that means x has to be greater than 0. So right off the bat, we can get rid of this. and the y value is positive, which means the y value has to be greater than 0 as well. So, correct answer is going to be letter A. Now, alternate approach you could take is you could again go to Desmos, start with the answer choices, graph out the first one, and see, is 8, 2 in the shaded region where they overlap? Okay, and the answer is yes, because 8, 2 is going to be right here. The region where they overlap is basically this quadrant, right in here. Obviously, the border doesn't count. That's why dashed lines, but um, it is in the shaded region of the solution to these two inequalities, so therefore it's the correct answer. If you did the others, you would see they would be in the other three quadrants, which is not where 8, 2 is located. All right, here we have a bunch of points, basically a scatter plot, and they want to know what's the most appropriate model or like basically best fit line for this data. So a couple things. First of all, notice the slope is negative because it is going downhill. Sorry, it's not -1. That's just supposed to be a negative sign. So therefore, we can get rid of these two right away. Now, also, second of all, notice that the y-intercept is positive. It looks like it's like somewhere right around 10, maybe a little over 10, a little under 10, but the point is it's a positive number. And we were comparing A and B, only one of them has a positive y-intercept to go with its negative slope. So the answer has to be B. You don't have to do any more work or anything else, to figure that out. However, if you wanted to, you could also, again, go to Desmos. And what we could do is we could just add a table. And we could just pick two of the points in here. So like, see, what are some good ones to use? Okay, so I'm just going to pick maybe this point right here. And I'm just going to estimate it. It looks like it's like 0.9 for the x and maybe like 8.8 for the y. And then for my second point, maybe we'll whatever, just pick this one right here. So that's going to be like, again, we're just estimating, and that's fine. 4.7 for the x and like 1.7 for the y. Okay. So now we're going to do is basically get the equation of this line by doing a linear regression. All right, so it gives us like for the slope negative 1.86 and for the y-intercept 10.48. So when you look at the answer choices, these numbers are pretty close, but there's only one that has a negative, value for the slope and a positive 10 point something for the y-intercept. And again, it confirms the correct answer here is letter B. Next up, question number 16. This is basically an exponential function equation that you're dealing with. I mean, they tell you, they tell you it's an exponential function right here in the problem. So first, I'm just going to show you how you could use process of elimination to basically get this answer without actually needing to solve it. So notice that you start with 36,000 and the amount you have after 13 years is more than that, 68,000 whatever. Okay? So it's increasing. That means we can eliminate C and D right away because the numbers they have here in the basically the base of the exponential, function, numbers being raised to the exponent to the t, is less than 1. That's what happens when you have exponential decay or decline. So since we're increasing, we need this number to be more than 1. So right off the bat, C and D are wrong. Now, when you compare A and B, notice that A has the correct initial amount in front. B does not. B has like some other number. I'm assuming it's the difference you get if you subtract, you know, the amount after 13 years versus the starting amount. In other words, B has in front the like amount that the balance increased by. So this one is wrong also. So by process of elimination, it has to be A. Now, just to show you like how that actually works out, how you could actually just confirm that. So you know that the amount after 13 years is the $68,071.93, and then that's going to be equal to the initial amount times 1 plus r to the t, but t is 13 because we're looking at 13 years. And then we're just going to solve this for r. So you divide both sides by 36,100 and you get 1.8856, just, kind of round it off, equal to 1 plus r to the 13th power. And now the way you cancel this out is you would raise both sides to the 1/13th power, because that 13 and the 1/13th will cancel out and just make 1. So you end up with 1 plus r equal to, basically it's 1.049999. I mean, if you use the actual, if you don't round it all during the process, it should probably come out to 1.05. But here you can see r is going to equal essentially just 0.05. So now, if you go back to plug that in, 1 plus 0.05, that makes the 1.05, and that just confirms that this is the correct answer. Now, another method you could use to solve this, it's kind of like, say, method 3, is back solving. Just go to Desmos, put in first answer choice, and put in 13 for t. And see, does it equal $68,071.93? The answer is yes, so that's the correct answer. If it didn't, then you would try answer choice B, see if it equaled the number you would expect after 13 years, and then move on from there. So this one you can back solve it. You can technically mathematically solve for R, or you can just use process of elimination to figure out that A has to be correct without even doing any of that work. Next up on 17, we have an absolute value equation. So here, I would just go to Desmos. I would solve this by typing in both equations, both expressions, basically the left side of the equal sign and the right side of the equal sign, seeing where they intersect, and those are going to be the solutions. So we've got one solution here at -1. We've got another solution locked in at 9. So which one is the positive one? Well, obviously it is 9. So that's the correct answer. You don't need to do any more work or go any further. However, I will show you, just as a refresher, here's how you could solve this out algebraically. Notice you have the same expression here, so you can treat this like a variable, and you can just add them together first and get 5 times absolute value 4 minus x equals 25, and then divide by 5. Absolute value of 4 minus x equals 5. And then you could set up two equations. Get rid of the absolute value signs on both. One is equal to +5, one's equal to -5. The one on the right is the one that we want because that's going to give us the positive solution, which is just going to be +9. The one on the left will give you the -1, which is not, not the answer to the problem. All right, next up we have a factoring question, but this one could also be solved in Desmos as well. And so I'll show you how to do that. So, but first, just a brief review if you're going to solve this by factoring. So you pull out a y to the fourth from the first expression, and you're left with 15y, and then you pull it out, from the second one, and you're left with just 9. But you also have this r here. So notice if you distribute this, you multiply these two together, r times 15, or 15r, has to equal 90. Similarly, r times -9, or -9r, has to equal -54. So solving either of these equations out, r must equal 6. So the correct answer to this is going to be 6. Now, here's how we could solve this problem entirely through Desmos. So notice, first of all, I'm going to use x as the variable instead of y, but that doesn't, change anything. And I'm also going to use a slider, okay, for the second expression. And basically what I'm looking for now is I need the two graphs to overlap or line up completely on top of each other. First, if I move to the negatives, notice that, okay, eventually it flips, and these are never going to be aligned. No matter how negative I go, these are not going to be equivalent. So I can ignore the negatives. I can go back to the positives, okay? Notice here they're starting to get closer together, starting to get closer together, but I'm going to zoom in just so I can see, for sure. Okay, so keep going, and then you can see right there at 6, it looks like, yeah, you can see like if you keep going, the purple one goes below. So if we go back to 6 and now notice, take one away. Okay, take this over top, take that off, it's still there. This one, this one. See, there's, it's the same graph basically. So that confirms that 6 is the correct answer for R. Now for 19, here you have an area problem. However, this one is very, very simple because the area of a rectangle is just length times width. And the expression you're given is W times W plus 9. So W is the width, like that matches up with the width here. So it's like scratch those out. So what does the W plus 9 have to be? Well, just the length. So correct answer, letter D. And, that's it. We can just move on to the next question. All right, here you have one with a single linear inequality, and they give you a bunch of points, and they want to know which of these are solutions to it. So a couple different ways you could do this. You can like go through the points and you could take the first one, say like the first point for A, and you could plug it in, and you're going to see that it doesn't work because it's going to give you 21 greater than 21. That is not true. They're equal, but 21 is not greater than it. So then you could eliminate A. And same thing with C. You could also notice that like if you plug it in, you're going to get 16 is greater than 21, which is false. So you could eliminate that one. And then you're down to B and D. And so you'd have to check some points like, 542 versus 552. Like one's going to work, one isn't going to work. And you could reason your way through it that way. I mean, if you plug in 42, for example, comparing on the right side, 13 times 5 is going to be 65, and you could, again, do this all in Desmos. 65 minus 18 is going to be 47. So you get 42 greater than 47. That is false. That is not true. So process of elimination, it's going to be letter D as the correct answer down here. And you could then take all three of them and just plug them in and confirm that they work. But the method I would probably use for this is Desmos. And so, I would go graph it out and then just start with A. Okay, y is greater than, yep, that's your next minus 8. All right. So now we're looking at the point 321. So yeah, scroll all the way up here. Okay. So again, notice 321. Here's 21. Here's 3. Okay, so it's this point right here. It's exactly on the border, but the border is not a solid line. It is dashed because it's not included in the solution. So that tells us that 321 is not a solution and does not work. So that's how we could eliminate A. And then if you go to B, okay, if you keep scrolling up, you'll see like 326. So again, I'm still on 3. Move it up here. Okay, 326. Is that a solution? Yep. All right, now we got to look at 542. So we keep scrolling up, keep scrolling up, keep scrolling up. Okay, I'm going to put my dot right on 542. Is that a solution? No, it is not. So get rid of it. 321 doesn't work, so obviously for C, 316 is not going to work either. I mean, if you're not sure, we could just jump down, scroll down, place it on, there we go, 316, not a solution. So again, by process of elimination, it's going to be letter D down here. 326 we already looked at. You can see 552 and 891. They're both going to be in the solution set or above the line. So again, correct answer for this one's going to be letter D. Now, let's talk about 21. Here you have a function and you are given a new function, which basically involves taking the original one and shifting it horizontally. And they want to know about the intercepts of the new function and basically just the sum of them, add them together. So if we go back to Desmos, I think the easiest way to do this is just going to be to graph the original function, and now we can easily graph g of x with the shift. So let's go back to the home thing here. Okay, we don't need f of x anymore, so we can get rid of that, so we're not confused. Okay, what are the x-intercepts for g of x? -5, -4, 0. Okay, so a plus b plus c, -5 plus -4 plus 0. Well, that's just -9. Correct answer is letter B, and we're done. We can move on to the next question. Now, I will show you, though, a way you could figure this out without needing to use Desmos at all, and that is this x minus 1, this minus 1 inside the parentheses, this indicates you're shifting to the right by 1 unit. So in the original function, since it's factored, we know that its intercepts will be -6, -5, and -1. So if you move them each to the right by 1 unit, you're now going to have new intercepts of -5, -4, and 0. So just go ahead, add those up. We get -9, same answer that we got from the graph. But maybe that's quicker, maybe that's easier. If you're able to identify that shift, then just add the values and do it that way. That's fine as well. All right, last question here on Module 2A, the easier of the second modules for Practice Test 3. And we have a square inscribed in a circle. So here we have our circle. Here we have our square. And they tell us the radius is 20 root 2 over 2. So first of all, I'm going to simplify this. I'm going to divide the 2 into 20 and just make this 10 root 2. So here's a radius, 10 root 2. Here's another radius from the center, 10 root 2. Together, these make the diagonal of the square. And now you could label each side x, because in a square, all sides are the same length. And we could just do Pythagorean theorem. X squared plus x squared equals, notice this whole thing is now just 20 root 2. So 20 root 2 squared. So 2x squared equals, now 20 squared is 400, root 2 squared is just 2, so 2x squared equals 800, then you divide by 2, x squared therefore equals 400, x is going to equal 20. So each side of this square will be 20, and that's it. One last thing just to mention though, or point out, you could also, if you recognized that this is a 45, 45, 90 triangle, because in a square, the diagonal divides the square into two congruent, 45, 45, 90 isosceles right triangles. The scale factor between the legs and the hypotenuse is square root of 2. From legs to hypotenuse, you multiply it. From hypotenuse to legs, you divide it. So you could have just recognized, 20 root 2 is the hypotenuse. I divide by root 2. Therefore, each leg has to be just 20. And you could get it that way without using Pythagorean theorem. All right, so that was Module 2A, the easier of the second modules on Practice Test 3 for the digital SAT, Bluebook app, math section, of course. If you have any questions or comments on this specific test, please do leave them below. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, sign up for notifications as well, and look out for videos on the first module from the same test and also the harder second module, Module 2B, from this same test as well.